Welcome to the deep dive.
Great to be here.
Today we're winding the clock back a bit. We're going to 2008.
Yep, looking at some really interesting source material around Warren East. He was the CEO of ARM back then.
Right, a really pivotal time for mobile technology. We've got, some reflections on his time there and a key interview.
Exactly. A detailed interview he gave in June 2008. It gives us a great snapshot of ARM's thinking, their strategy, their vision for mobile processors, just as things were really heating up.
Okay, so our mission today is to kind of unpack ARM's position back then. What were they seeing?
What were the big challenges, the opportunities they were focused on?
And maybe see how much of that vision connects to, the phones we all carry around today. Should be interesting.
Definitely. Let's dive in.
So maybe set the scene for us. Warren East in 2008. What was his background leading up to that point?
Sure. So he'd had a pretty solid background, spent 11 years at Texas Instruments first.
Okay, TI, a big name in chips.
Exactly. Then he joined ARM back in '94, actually helped set up their consulting side initially.
Ah, so right from the fairly early days of ARM then.
Yeah. Worked his way up, VP Business Ops, COO, and then CEO from October 2001. So by 2008, he'd been leading ARM for a good while.
And just as a side note, he went on to lead Rolls-Royce later, right? Through some pretty turbulent times, too.
That's right, a significant figure. But focusing back on 2008, ARM itself was just dominant in mobile.
Yeah, the sources really highlight that. What was the figure? Something like 90% of mobile phones?
Around 90% of the world's mobile phones had ARM tech inside. Just staggering dominant.
Unbelievable. And this specific interview, June 2008, you mentioned it might relate to a meeting in India.
Yeah, the timing suggests it might reflect discussions around a meeting in Bangalore, maybe May 7, 2008. So very current thinking for that time.
Okay, 90% share. Clearly, they had a strong strategy. What did the sources tell us about how they were thinking, particularly about markets like India?
Well, their India strategy was pretty key, and it tied into their whole business model.
Which was licensing the IP, right? Not making chips themselves.
Exactly. They provide the intellectual property, the designs to semiconductor companies.
Like the Qualcomms or Texas Instruments of the world?
Precisely. And those companies make the physical chips and sell them onto the phone makers, the Nokias, Samsungs, Apples.
Got it. So what was the specific goal for India, for their Bangalore Design Center?
It was ambitious. East is quoted wanting it to be the Cambridge of Asia.
Cambridge of Asia. Wow. What does that imply? Just high-end engineering?
High-level design capability, definitely.
Yeah.
But it wasn't just about hiring engineers. They were really focused on building the whole ecosystem there.
Ecosystem meaning?
Meaning a network of companies, universities, talent, everything needed to support advanced semiconductor design.
And why India specifically? What was the draw in 2008?
Two main things, really. First, the domestic market was seen as huge and growing fast, both consumers buying phones and Indian companies starting to design their own electronic products.
So being close to the customer base.
Right. And second, they needed to build the ARM brand within that growing semiconductor design community in India. Be part of it, understand it, influence it. It was about presence and integration.
Makes sense. Strategic positioning. Okay, let's switch gears to the actual technology, the processors. What was the roadmap looking like in 2008, according to these sources?
So the main processor shipping in high volume then was the ARM11.
ARM11.
The interview mentions it was something like 40% of their ship volume in the last quarter purported at that time. And here's the kicker.
Yeah.
The ARM11 was the processor inside the original Apple iPhone.
No kidding. The original iPhone.
Yeah.
Wow. Okay, so that puts it right at the heart of the smartphone revolution starting.
Absolutely. So they weren't just in most phones, they were in the phone that was changing the game.
But they weren't stopping there, obviously. What was next after ARM11?
They were already pushing the next generation. The Cortex A8 was coming online, but the big focus in this interview was the Cortex A9.
Cortex A9. And where was that in mid-2008?
The IP had basically just launched. They were delivering early sort of beta versions to their lead partners, the chip makers.
Okay, so the design was ready. Partners were getting their hands on it. What about phones people could actually buy? What was the timeline?
They were expecting production-ready IP towards the end of 2008.
Right.
And then phones using Cortex A9 processors hitting the market probably by the end of 2009.
End of 2009. And when would they expect it to be really mainstream?
They predicted significant volume shipping between 2011 and 2012.
Which, looking back, feels pretty spot on, doesn't it?
Yeah, that timeline seems remarkably accurate.
And the big draw for Cortex A9, what was the performance promise?
This is the headline number.
Yeah.
Cortex A9 was designed to deliver 8 times the performance of ARM11.
8 times. That's a massive jump.
Huge. A real step change in processing power for mobile.
So what kind of improvements did East see this enabling for users? What could you do with 8 times the power?
Well, interestingly, a huge focus alongside the performance was actually on power consumption.
Ah, okay. So faster, but not necessarily draining the battery 8 times faster.
Exactly. They aimed for much lower power consumption than you might expect for that performance leap. This was crucial because phones were starting to do a lot more.
Right, and networks were getting faster too, with 3G rolling out more widely.
Precisely. You had these wider data pipes from 3G, so you could potentially do more, access richer content. But the processor had to be efficient enough to handle that without killing the battery life.
So better efficiency enables taking advantage of the better network. What kind of experiences did they mention specifically?
They talked about enabling much better video playback and, significantly, a much better internet browsing experience.
Browsing was definitely clunky on early
It
smartphones.
really was. And they saw the combination of faster networks and faster, more efficient processors as key to improving that.
Were there any sort of future applications mentioned, things that seemed like science fiction then but might become possible?
Yes, actually. There's a fascinating bit in the source where East talks about real-time speech translation.
On the phone in 2008.
Yeah. He suggested that with enough processing performance, like what Cortex-A9 was promising, software-based speech translation could actually work in real time right there on the device.
That's incredible foresight. Predicting something we kind of take for granted now with cloud services, but predicting it based on on-device processing power back then.
It really shows they were thinking ahead about what that performance could unlock.
But you mentioned the focus on power efficiency. Was there a big challenge they were running up against?
Oh, definitely. East was very upfront about the battery problem.
Battery itself.
Yeah. He basically acknowledged that battery technology, specifically the standard lithium-ion batteries, just wasn't improving at the same pace as the processors or the demands of the new applications.
So the chips were getting faster and faster, but the power source couldn't really keep up.
Exactly. He saw it as a major constraint. Lithium-ion wasn't getting much denser, charging wasn't getting much faster relative to the need.
Did he mention any alternatives? People were talking about fuel cells and things around then.
They were mentioned, yeah, but not seen as a practical solution for handsets anytime soon. It was still lithium-ion for the foreseeable future.
So how did ARM frame that challenge? Just tough luck.
No, he actually framed it as an opportunity for ARM. Because the battery was a constraint, it made ARM's focus on power efficiency even more critical. If they could deliver performance with less power drain, that was a huge selling point.
Right, turning the limitation into a driver for their own innovation. Smart. You also mentioned browsing. East said it wasn't great in 2008, even with ARM11 in the iPhone. Why did he think that was? Was it the chip?
Interestingly, no, he didn't primarily blame the processor speed for the poor browsing experience back then.
Ooh, so what was the issue then?
He pointed mainly at the phone applications, the software, and crucially, the websites themselves.
Ah, websites designed for big screens.
Exactly. Most websites were built for computer monitors, desktops with keyboards and mice. Trying to render and navigate those complex sites on a small phone screen, often with just a D-pad or rudimentary touch interface, were the real problem.
Makes sense. The whole ecosystem needed to adapt, not just the processor.
Right. He did note the good news was that this was starting to happen. Websites and apps were beginning to be designed more with mobile in mind, but it was early days.
Okay. So, roadmap is pushing performance, efficiency is key due to battery limits, and the software world needs to catch up. What about the absolute cutting edge of chip manufacturing itself? The move to smaller transistors. Where were they with, say, 32 nanometer technology?
Yeah, the 32 nanometer node was definitely on their radar and in progress in 2008. The sources mentioned some of that development work was actually happening in the Bangalore Center.
Back to the Cambridge of Asia goal.
Ties back in, yeah. But it was still an ongoing project at that point, not fully baked.
And what paced that development? Could ARM just design for 32 nanometers whenever they wanted?
Not quite. East explained that their development of the physical IP, the actual layouts and components for 32 nanometer, was tied pretty closely to the speed at which the manufacturing processes were being developed by the foundries, the chip factories.
So they depended on the TSMCs or global foundries of the world to actually figure out how to build reliably at 32 millimeter.
Exactly. They couldn't design stuff that nobody could build yet. There was a dependency there.
And this constant shrinking 65 millimeter, 45 millimeter, then 32 millimeter, how did they view that? Was it just getting harder and harder?
He framed it quite simply as the way of progress in semiconductors. Yes, it added complexity. New challenges pop up when you shrink things that small.
Sure, physics gets tricky.
Right. But ultimately, he saw it as fundamentally beneficial for the user. Smaller transistors mean more function, more efficiency on the chip. The roadmap looked similar, conceptually, across these different nodes.
And the goal for 32 nanometers specifically was just to have everything ready.
Pretty much. To have the full set of physical IP, all the building blocks, functions, features they needed for their target applications, ready to be implemented on the 32 nanometer process once it was mature and available from the foundries.
Okay, so they're driving the roadmap, working on future nodes. What about outside pressure? Competition. We know Intel was making noises about getting into handsets around this time.
Yes, Intel was definitely trying to push its Atom processors into the mobile space, challenging ARM's dominance.
How did ARM and Warren East specifically react to that, according to the sources? You'd expect them to be maybe a bit defensive.
It's actually one of the most interesting parts. The source material quotes East as saying he welcomed Intel's initiative.
Welcomed Intel trying to take their lunch money. That sounds bold, or maybe just confident.
Right. It does seem counterintuitive. His stated rationale was that Intel's entry would spur competition.
Spur competition. Okay, like a rising tide lifts all boats, or maybe more like competition keeps us sharp.
Probably more the latter, I'd guess. A very confident stance, basically saying, bring it on.
So, okay, they welcomed the competition, at least publicly. What was their actual strategy to beat that competition and maintain leadership?
It seemed to be multifaceted. First, just relentless focus on their customers, the chip makers licensing their IP, making sure the ARM architecture offered a more compelling overall experience for them compared to, say, by '86 from Intel in mobile.
Compelling in what way? Performance, tools, support.
All of the above, likely. He mentioned providing everything their customers required, specifically calling out things like application support on the internet, ensuring the software ecosystem was strong around ARM.
And did their business model play into that strategy too, the whole IP licensing thing?
Yes, he highlighted that. The model meant their customers gained deep experience in building complex system-on-device applications using ARM cores.
So the chip makers got really good at using ARM technology.
Exactly. And East saw this experience within their customer base as something that actually fed back to ARM. It helped inform ARM's future IP development, making it better and more relevant. It created this reinforcing cycle, almost like a shared expertise ecosystem being a competitive advantage.
Fascinating. So the ecosystem itself was a defense mechanism.
It seems like that was a big part of their thinking, yeah.
Okay, so if we step back and look at this whole picture from 2008 based on these sources, what are the big takeaways for you? What really stands out?
For me, it's that combination of their already incredible dominance, but combined with a real lack of complacency. They weren't just sitting on that 90% market share.
Right, they had the iPhone chip, but they were already focused years ahead.
Exactly. They were very aware of the real-world limitations, battery life being the big one,
Yeah.
the state of mobile web browsing. And they were actively mapping out solutions through their processor roadmap.
Yeah, that eightfold performance jump with Cortex-A9, the focus on efficiency, even predicting things like real-time translation. It was ambitious stuff for 2008.
It really was. And it's striking how many of those things they were focused on, better browsing, video, power efficiency, really did become the defining improvements in smartphones over the next few years.
It shows how those foundational technical decisions and strategic bets made way back then really did shape the mobile world we have now. They weren't just reacting, they were laying the tracks for where the train was going.
Definitely. And the global strategy piece, like the Cambridge of Asia ambition for Bangalore, and that confident, almost welcoming stance towards competition from Intel, it paints a picture of a company that really understood its position and how to defend and extend it.
This whole deep dive really underscores that connection between past vision and present reality.
Which kind of leads to a provocative thought for you, the listener. Maybe.
Bring it on.
If people like Warren East, looking at the tech trends back in 2008, could foresee so much of what our mobile world looks like now based on processor roadmaps and network evolution, what are the equivalent foundational discussions happening today?
Like AI on device, maybe?
Yeah.
Or new battery chemistries, quantum computing impacts?
Exactly. Or pervasive sensing, different kinds of network fabrics. What are the core technological challenges and roadmaps being debated right now that will fundamentally define your digital life in, say, 2034?
That's a great question to ponder. What seeds being planted today will become the landscape we live in a decade from now?
Something to think about.